Hey guys, I'm going to go over the practice book answers for the last section, Newton's Law of Universal Gravitation. So please get out your books, open to page 339, and follow along. Again, you don't have to correct what you got wrong, but just if you have a question about it, make sure you ask me. Number one, air offers resistance to the motion of objects through it. Air, anything really offers resistance when something is going through it. It's part of friction or whatever. And air is a fluid, not a liquid, a fluid, and it flows around things. Two, Galileo concluded that objects accelerate. Sorry, I just thought I heard a fly or something. Galileo concluded that objects accelerate steadily as they fall, and that an object's weight or mass does not affect how fast it accelerates when falling. Sorry. 3. An object is pulled to Earth by gravity, an attraction between the mass of Earth and the mass of an object. 4. Objects with a large mass are pulled on by gravity with more force, but they also have more inertia. So things are pulled by gravity with more force, but they also have more inertia. Makes sense. More mass is harder to stop. Number 5, the force of gravity on any object is called its weight. Remember, weight is not just a constant thing, but it's an appearance, how heavy something feels. 6, an object's weight in newtons can be found by multiplying its mass in kilograms by 9.8. The speed of any object falling to the ground increases by 9.8 meters per second each second. That means after 1 second, the speed of any object will, as long as you don't talk about air resistance, any object will be 9.8 meters per second. After 2 seconds, it will be 19.6. After 3 seconds, it will be 27.4, like that. Any single object. 8, a combination of the moon's inertia and the force of gravity between the Earth and the moon keeps the moon orbiting around the Earth. Number 9, Newton decided that as mass increases, the force of gravity also increases. So mass and gravity, the same. 10, Newton's law of universal gravitation states that the force of gravity between two objects increases with the mass, decreases with the distance. For light objects, the force of gravity is weak. For massive objects, or objects with a lot of mass, like moons and everything, the masses are so large that the force of gravity becomes very large. 13, we are accustomed to gravity giving things on Earth weight, including our own bodies. 14, in cycling, the weight of the rider and the bicycle presses the tires against the ground, creating friction, which gives the tires traction. Page 341, you have the two masses there. Number 1, if the 1 kilogram object is being pulled by gravity by a force of 9.8 newtons, how many newtons of force does the gravity exert on the 2 kilogram object? So everything, remember, how much gravity is pulling, it's essentially saying what is the weight. To find out the weight, you take the mass and multiply by 9.8. Look at number 1, the 1 kilogram object. The mass, which is 1 times 9.8, equals 9.8. So now we have a 2 kilogram mass. So we're going to have a mass multiplied by 9.8, 2 times 9.8. We should have gotten 19.6. Number 2, and in units would be 19.6 newtons. Number 2, if acceleration equals force divided by mass, A equals F over m, that's Newton's second law. What is the acceleration of each object if the force of gravity on the 1 kilogram object is 9.8 newtons, and the force of gravity on the 2 kilogram object is 19.6 newtons? What is the acceleration? Note acceleration is expressed in meters per second each second. So basically what it's asking, this one probably sound tricky. And so what you're saying is, it's asking what is the acceleration? And so you take the force, which is weight, the weight divided by the mass. So the 1 kilogram object is 9.8 divided by 1, which, can you guys do that? 9.8 divided by 1? 9.8. And the 2 kilogram object is 19.6 divided by 2. You do 19.6 divided by 2, and you get 9.8, right? Each object is being accelerated at 9.8 meters per second each second, 9.8 meters per second squared. So That's what we found out, obviously. Number 3, how many newtons of force would gravity exert on a 3 kilogram object? Well, you know, a 1 kilogram is 1 times 9.8. 2 kilogram is 2 times 9.8. So what would a 3 kilogram be? 3 times 9.8 is 29.4. I think it's a 27.4 before 29.4. Next, page 342. The moon moves at a constant speed of what around its orbit? It's just right there on the page, 1,030 meters per second. Number 2, is the moon's acceleration expressed as a change in speed or a change in direction? It's expressed as a change in direction. It is actually anything traveling in a circle is constantly changing direction. Each instant, it's changing, it's turning every single second. It's going actually at a constant speed. The speed is not changing. The direction is changing. Number 3, if the moon was suddenly released from Earth's gravity, what would happen to it? Would it still be experiencing acceleration? It would fly. First of all, it would fly off in a straight line into the depths of space. You guys should have gotten that one. And would it be accelerating? No. It would actually be moving at a constant speed in a straight line. So therefore, it is no longer accelerating. Page 343. The force of gravity. Number 1, the force of gravity on any object is called the object's weight. That's what the weight is, the force of gravity, how heavy something feels because of the force of gravity. Number 2, the force of gravity between two objects increases when the mass of the objects, with the mass of the objects, meaning when the mass gets bigger, the gravity gets bigger, but it decreases with the distance. When you get them farther apart, it decreases. If we ignore air resistance, all objects accelerate to the ground at what rate? 9.8. Number 4, scientists have learned that when the effects of air resistance are removed, objects of different weights fall at the same exact rate. A bowling ball and a tennis ball will fall the same rate. Oh, I'm frozen. Keep going. Keep listening, though. Number 5, Newton's law of gravity is universal because it applies to any objects, not just moons, planets, and stars. That's why we call it universal. Universal means, having to do with everything. Number 6, an object is pulled to Earth by gravity, an attraction between the mass of Earth and the mass of the object. Number 7, a combination of the moon's inertia and the force of gravity between Earth and the moon keeps the moon orbiting Earth. Number 8, explain how weight might help keep a car on the road from spinning off a sharp turn. Okay, so if you add weight, how can it keep a car from spinning? The added weight would push the tires more firmly into the ground, increasing the friction between the tires and the road. The added friction and the inertia of the larger mass would keep the car from spinning off. Number 9, how did Galileo test his theories about objects of different masses falling at the same rate? What he did was he had experiments basically that involved rolling marbles down ramps and dropping two objects with different weights off a tall tower to show that they'll hit the ground at the same exact time. 344. Aristotle believed that heavy things fall faster than lighter things. Later, Galileo reasoned that objects fall at the same rate, ignoring air resistance. To test his ideas about falling objects, Galileo carried out experiments that involved rolling marbles down ramps. He also talked about dropping two objects with different weights off a tall tower to show that they would hit the ground at the same time. Galileo concluded that objects accelerate steadily as they fall, and that an object's weight or mass does not affect how fast it accelerates in falling. We know that today that Galileo was right. An object is pulled to Earth by gravity, an attraction between the mass of Earth and the mass of an object. Objects with a large mass are pulled on by gravity with more force, but they also have more inertia. This extra resistance to motion exactly offsets the greater pull of gravity on them. Therefore, objects with greater mass fall with the same acceleration as less massive objects. All right, those are those problems. I will be giving you the study guide soon.